What if I told you that the same sand you find on almost any beach can power your entire house? Every second, the sun sends about 173,000 terawatts of energy to Earth, roughly 10,000 times more than humanity uses. Most of it simply bounces back into space. So if we have access to that much free energy, why are we still paying electricity bills? The answer lies inside the solar panel. It all starts with silicon, the second most abundant element on Earth, extracted from ordinary sand. But before it can generate electricity, it must be purified to 99.999%, formed into large crystal blocks and sliced into ultra-thin wafers. Here's where physics becomes fascinating. Pure silicon doesn't conduct electricity well because its electrons are tightly locked inside its crystal structure. To change that, engineers intentionally add tiny amounts of other elements, a process called doping. One side receives phosphorus, creating extra free electrons, known as N-type silicon. The other receives boron, creating missing electrons, or holes, called P-type silicon. When these two layers touch, electrons rush to fill the holes, creating an invisible electric field at the boundary called the p-n junction. This electric field is the heart of every solar cell. Now sunlight enters the story. Light is made of particles called photons. When a photon strikes the silicon with enough energy, it knocks an electron free. Instead of moving randomly, the electric field pushes that electron toward one side while the hole moves in the opposite direction. This separation creates voltage. Connect a wire, and the electrons flow through the circuit, powering everything from a light bulb to an entire home, before returning to repeat the cycle again. What's remarkable is that nothing is consumed. The silicon isn't used up, the electrons are recycled, and there are no moving parts. That's why many solar panels still work after 40 years. So why isn't the whole world running on solar energy? Current commercial panels convert only 15 to 20% of sunlight into electricity. The rest is reflected, lost as heat, or wasted before reaching the circuit. Solar power is also intermittent. It disappears at night and weakens on cloudy days, making energy storage essential, and today's batteries remain expensive. There are also economic and political barriers. High installation costs and decades of investment in fossil fuels have slowed the transition. Yet for more than 1 billion people without reliable electricity, solar power is already one of the cheapest and safest energy sources available. So let's return to the original question. If the sun gives us 10,000 times more energy than humanity needs, why aren't we using it? The science already works. A thin slice of purified sand engineered at the atomic level can transform sunlight into electricity for decades. What's missing isn't the technology. It's the scale, the storage, and the decision to build the future.